We started by learning about an Arduino, what it is, how to use it, what are the different settings. We also got to solder a PCB together to learn how that works. We also created our own PCB as a part of the lab, but we ended up using a pre-made one just to make sure that everything works out the best, and we soldered all the components on that PCB ourselves. Once our PCB was ready, we ran several tests on it, starting with the bench test, where we kept the PCB on a bench and made sure that we were getting data for the acceleration, pressure, temperature, and all other data points. Then we moved on to the spike test, where we made sure that each sensor could respond to immediate changes. Then we moved on to the elevator test. In this test, we put our PCB on an elevator, took it up 8 floors, stopped twice in the middle. We just wanted to make sure that we can derive height from pressure using an equation, and we can integrate acceleration to get height. And as it can be seen, our results and our trends of the graphs were very similar, which means that our pressure and accelerometer were not only accurate, but they were also precise. And then finally, we did the simulation test, where we either found a bunch of values online, or we used our own rocket, or we did experiments, and we used those values to create a simulation. And according to the simulation, our rocket would go up 519 feet and it would be in the air for 62 seconds. The final part of the pre-launch preparations were to build our rocket and make sure it's ready to go before the day of the launch. What an awesome day, but this is our team's first launch. Unfortunately, our Arduino stopped recording data, so we could not analyze any data from this launch. Our second launch, Arduino did record all the data. However, we had an engine malfunction where our parachute deployed at 3 seconds instead of 5 seconds, and because of that, our rocket couldn't go as high, and because of that, our parachute also burned a little bit, and as you can see, there's Julia trying to run and catch it. After analyzing the data, these are the maximum heights we found from both of the sensors. Unfortunately, once again, we could not reach the 500 feet goal because our engine deployed our parachute too early. There's a bit of a difference between the two heights, and that's because our parachute did not work properly and caused our rocket to flip around, which means that our acceleration got divided between the 3 axes.